So can you all see my screen?
No, ma'am.
Yeah.
No. Now. Yes, ma'am. Now it is visible, ma'am. Now it is visible, ma'am.
Sure. Thank you, sir. All right. Thanks everyone for joining today, and thank you sir for that intro. And I see Tamil Mani sir on the call. Sir, how are you? It's been so long.
I'm fine. How are you?
I'm good, sir. Thank you so much for joining. It's a pleasure today for me to present this. It's been over 7 years since I graduated, and doing the same thing in college is that's a proud moment. Thank you so much. And good evening, everyone. Thanks so much for joining today and your time. I know it's a good evening, and I'll try to make it more interesting. All that I want is I just wanted to make sure we have an interactive session. Just feel free to stop me if you have anything that you wanted more to hear about. And also, if I'm going too fast, just let me know, all right? Thanks, everyone. So let's go ahead and get started. So today we are going to be talking about supply chain management and quality management system in manufacturing. So that will be the main focus. So a little bit about myself, as Sir mentioned. One second. As Sir mentioned, I'm an alumni from our university. I graduated in the year 2013, and after which I went on to pursue my master's in electronics and control engineering. Once I completed that, I started my career in Flextronics. And in Flextronics, I was working for trade compliance and supply chain. The main reason I was into Flextronics is because it was an electronics manufacturing industry, and then that is where our core knowledge was used, and it was prevalent there. And moving forward, I went to the US to pursue my MS in industrial management, and after which the whole thing started. I worked for Abbott and many other companies meanwhile. So this is just in short about myself. So let's do that. Okay. So the agenda, can you all see me? So is my video on?
The PPT is visible, ma'am.
What is it, sir?
PPT is visible, ma'am.
Is my video on?
No, ma'am. Video is not on.
Yeah, because I try to put it on. You can share your video. Okay. Since my screen share is on, I'm not able to actually use my video. So if that's okay, I'll just continue.
Okay, ma'am.
The introduction. So it will be the introduction, and then I'll explain about what a product life cycle is, the supply chain management, the supplier quality, and moving on with that, we'll get deep into Six Sigma and what a quality management is. Then we'll wrap up with the question sessions. All right. So I work for Abbott Vascular in California, USA. So this company, what we do is we manufacture. I guess I'm just having some disturbance over the call. Is everybody on mute?
Yes, ma'am. I muted now.
All right. Sounds good. All right. So some of the products that we manufacture are from cardiovascular, diabetes. We go to diagnostics, neuromodulation, nutrition, and pharmaceuticals. I work for cardiovascular products. And then just to give a recent update, Abbott was one of the first companies to, start the testing kits for the COVID-19 here. And then the latest test that we have is the Binax now. It is like a chip reader where where the nasal swab is taken, and then once if the tests are negative, you get a pass through which you can access the public areas in the US. So that is our latest innovation, I would say, that was just launched 2 weeks ago. So this is all like just a high level background of what we do. Moving on, I wanted to start with giving a brief about what a product life is and then go from there. So as we all know, product has like multiple stages. Just to put it in a very simple terms, it has a beginning of life, a middle of life, and the end of life. So beginning of life is where the prototype is being tested and where we start with the design and manufacturing process. In an industry, the most of the engineer support is needed in the first phase of the product life cycle, very specific to designing and implementing the manufacturing process and to build all the prototypes. Electronics engineers here take a part in designing, and as well as so some of the tools that we use inside the industry is CAD and AutoCAD are the major tools that we use for designing right now. And moving forward with that, the middle of life. So middle of life is where I deal with the products. That is where my primary concentration is right now. I work with the post-launch market support. So that's basically once the product is manufactured, how is it going to go and reach to the customers, right? So that is where the supply chain and quality management system and everything comes in role. I would like to explain more in detail about that in the coming slides. And the last part is the end of life. That is where, a reverse engineering happens to be more precise. Just to give a very simple term, like if you buy a product from Amazon and then you ship back, right? In case if you don't like it, you return. So that is where the reverse engineering happens, and the reverse logistics, to be more specific, that's the end of the life. So product, when it's manufactured and it goes back to the inventory, and then it just keeps storing there until if there's going to be a potential use in the future. So all those are like basics of the product life cycle. As we can see in the diagram in the right hand side, we have a beginning of life. Okay, so all the engineering team, the R&D and design engineers, they work in the BOL stage. And after that, in the MOL stage is where we have more of the business analysis, supply chain management, and the quality system, trying to work on teams where they're trying to take the product from the manufacturing line and give it to the customers. And then EOL is a combination of the first and the second stages. You have engineering teams and as well as the management teams involved in that stage. All right, so let's go on to the next one. So supply chain management. So what is supply chain management is basically, if you see in the diagram there, how a product starts from a raw material and it goes all the way through a customer. So to be more specific, I would quote on a cardiovascular product. Okay, so that's what we deal with. So a raw material is basically taken from a third-party manufacturer. And then after that, we have different types of suppliers, and I will talk more about the suppliers in the coming slides. And then the manufacturing unit. So manufacturing unit is where the whole engineering team starts working, starting from the production line to assembly, packaging, and labeling, and until the end of the door. So that is where the whole support of the engineers are needed there. Let it be electronics engineer, IT support, quality engineers. So there's a different types of team they work there. So there's a potential scope for a future student to have concentration there and learn more about how, if you have a passion to get into manufacturing, I would say you can just follow the leads that I present after this, and then we can go from there. So my part involves a little bit of manufacturing and more of distribution there. So distribution involves supply chain. So that is one of the key roles of what I do. And there is like different softwares that we use on a day-to-day basis and a tracking system. Like, when you start a product, all that you need to know is what is the need in the market, right? So you have to plan your supply, you have to plan your demand, and then work on different variables there. So some of the softwares that I would suggest if you wanted to get into the manufacturing and distribution here is ERP, that is an enterprise resource planning. That's right now we are using that in the market. And SAP is a familiar software across the world. And then warehouse management system and inventory management system. You definitely need engineering skills there as well. It's not just about the supply chain, but a lot of engineering a background is needed to implement all of these. So we have supply chain engineers to be in specific, where they have a mixed skill set of management and engineering background. All right, so let's go on to the next one. Okay. As I was talking earlier, like the raw materials are usually got from the suppliers, right? So I work for a supplier quality as well. So anybody cannot be a supplier for a company. So there is like certain rules and regulations that we have to follow, and also the suppliers have to follow for us to be partnered with. Okay. So some of them, to start off with, as we all know, suppliers are like they play the integral part of the overall industry, and we have certain guidelines which we will know later. So those guidelines have to be followed for them to be our suppliers. Okay. So to be more specific, what an engineer does this is, okay, so we can take a simple product like in vascular division to be the cardio products, I would say we manufacture different types of material like stent system and then guide wires, and there's so many other pacemakers. This is all we do. For example, if you wanted to, like, if you take a pacemaker, the small electronic component, say if it's going to be a digital display, we might get it from a third party manufacturer. So that time, what a supply quality engineer does is their role is to make sure the supplier are in compliance with all the rules and regulations that is laid out by the company and as well as by the FDA, which is the Food and Drugs Administration. So they are the one who handle all the US manufacturing specific to the guidelines specific to the medical device manufacturing. So primarily an engineer, like, coming from electronics and instrumentation background, this is one scope of area where it was like really useful for me, because we have to go make sure, like, if the ICs or the processes or everything is like working, and we do actually do the test method validation as well. So this is something, if you wanted to look somewhere outside of our core but still wanted to stay within our core engineering, you can check out this stream, and it's really good. And it's also like all the supplier quality is being like a trend in most of the industries right now. So that is another area that I just wanted to emphasize. So as you know, like the compliance are developed in accordance to the industry standards responsible for supply chain. So some of the standards we might see later. And to be more specific, the standards differ for each country, and it completely depends on the organizations that's developing the standards. I could talk more about what is happening in the US. We have the FDA. Without FDA specifically for medical device industry, we cannot authorize or sell any product outside. So that's what. And also, as we all know, environment and is very important when it comes to a production floor or a manufacturing industry. As we are all engineers, we have to make sure that there is no negative impact to the society as well in terms of environment. So OH is very specific about all those things. So you have to make sure those standards are also met. So little bit of learning about that will actually be useful. I would say, since Kamalmani sir is here, he taught me environmental engineering back in 2012, I believe. So that subject is a really cool subject, and it has more connections to what we do as in a EHS perspective. Okay. And next thing is risk management, continuous improvement, and business continuity plan. So those are some of those key areas where I was studying was not a part of my curriculum. So I don't know if things have changed right now, but if you're more interested, you can just go and learn about that. So risk management is another trending, I would say it's a scope as well for engineers. And in risk, all that you do is like, what if a product fails, right? What are the possible risk of failure of a product or something happens in a distribution line? So once you have more of a product knowledge, you can also be a risk assessment engineer. So that is another area where we have to use our engineering skills. All right, so do we have any questions so far? All good. All right, so let me go to the next slide. So Six Sigma. So Six Sigma is one of the tools that we use in manufacturing. Myself, I am certified in Six Sigma as a green belt. Okay. So any industry, when we see, we don't want anything to be wasted, right? So all that is, we have to be cost efficient and product has to be efficient and yield. The maximum yield that we can take matters a lot in an industry. So when it comes for manufacturing, even a simple things like, if you visit a plant, you must have known, you'll have those yellow lines where you're not supposed to cross. You'll have an assembly line where everything is in place. All of these comes under the Six Sigma, to be more precise. So each and every term and everything that we do in an industry falls under Six Sigma, and not all industries follow that. It was developed by Toyota Corporation, and then many other industries have taken that. And some of the companies that I've given is just as a gist, and more of all those companies is where as instrumentation engineers, you'll have like a lot of scope. And Six Sigma is one area where if you can learn that, it will be really good. So I would just start with telling like what does it mean by 3.4 defects per million opportunities is basically if there are million opportunities, we just wanted to make sure you have just 3.4 defects, which is basically 99.99% yield. This is what every company tries to achieve so that there is no waste, and then they can also improve the profit performance and other key areas of business, right? So to implement all of these, you need someone who has an engineering background, who's well versed in product knowledge and also like risk assessment. So all these combined together is what Six Sigma is. So if you're trying to lean more towards getting into a production floor, actually being on the floor and working with the products, I would suggest like to get more knowledge on this. All right, so let's go on to the next one. So there's like different tools and techniques that are used. Sorry. Can you all not see my? Okay. So there's like different tools and techniques that is being used in Six Sigma. All right, to be more specific, what I used in an industry or what the medical device industry follows is DMAC. So DMAC is a whole different topic. It's like a different domain and it's a very broader topic. So, but just to give a gist of what that is, as you can see, DMAC stands for define, measure, analyze, improve, and control process, right? So anything that you start doing with the process, you just first define what the goals are in a process. So I would relate this more to our project work to be more like, just to give a lifetime example. So first, when we start a project, we kind of define what our project is, right? And then the next step that we do is we collect data, like we research the papers and then things like that, and then we choose our team members. So that will be like the second part. So similarly like that, when you measure the different variables for manufacturing, you take into account all of that. Analyze and improve are basically where you do the work, like you work on your project. And then improve is more like when we have the reviews and everything, right? So we get feedback, and as every review goes, we keep improving our project. So that is what improve and control phases. So this is a very high level example, and which we can relate to our our college stuff. But yeah, there's more or like that is what they do in an industry as well. Okay, so if you're interested in getting again into deep into manufacturing and working there, DMAC is a really good area to like develop your skills. So as you can see, the other things are like 5 years. 5 years is actually a very interesting one, and most of the office spaces also use 5 years. Like if at all you take a chair from a cubicle, you just put it back in the same place, right? So that is also a part of a 5 years, and which also falls under Six Sigma. And there is like always when you have something organized, it is proven that it increases the productivity. So in an assembly line, if you see, everything will be on place, right? And if something is not, if it is swapped, it could reduce the productivity in a very high level scale. So that's where 5 is very important. And so the next topic will be 7 waste, right? So as I mentioned earlier, the main goal of Six Sigma is we have to increase the productivity and also eliminate waste, right? So we should not have any waste. Waste in sense, I literally don't mean the waste, but anything starting from time, transporting, over processing, everything is a waste is considered in a manufacturing industry. If a worker is going to be working additional hours more than what he has to do, that is also considered as a waste. And then because it increases the production time, and also it increases the the budget and things like that in a business perspective. So such things are also accounted. Small things are also accounted, and then we just do the reverse engineering there and try to fix the problems, right? So that is something I could say there. And other example is if at all you order, and I mean, I'm trying to quote Amazon again, is because it's more relevant to all of us. And so if at all you order a product in Amazon and then it takes you time, like, it doesn't arrive on the time it has to arrive, and then it just comes later than that. That is again a waste of time and transportation. So if you just translate that in a business perspective, you can obviously return the product, so which is going to be again transportation and inventory cost are involved in that, right? So certain things like that play a very major role in a business perspective. So it's not just we return the product, but there's a lot of cost involved to that, which the customers are not aware of, but the company. So things like that is where we try, like the engineers and the management people, we try to actually get in there and try to see the ways of reducing it, right? So that is again one more thing. So next thing is the value stream mapping and flow. So they both are linked to each other. So this is pretty much like, I would say, like the flow charts that we have, right? So that is what in a very high level, when they do it in a manufacturing, there are certain symbols and codes where you build the whole value stream mapping. So the value stream mapping, I would say, has two stages. It has the past stage and also the future stage. So the past stage of the value stream mapping is, it's like the first stage when you start. So if you're a design engineer, you also will, like, touch a little bit about the value stream mapping, because they are a part of the BOL, right? So beginning of a life of a product also relies on a value stream mapping and the flow. So the same way what happened is you have a future state as well. So the future state mapping is basically when it comes to the end of the life. So if you're an engineer, if you're involved in either of the first or the third phase, you would definitely, if at all your industry is using Six Sigma, value stream mapping is something that is very simple, and it's also interesting to learn. So you can learn that. All right. So the next thing is a visual workplace. I think there's not like a much of explanation needed. There is basically your workplace, how visually you represent, right? So that's what it is. And the last thing is the voice of customer. So voice of customer is important in each and every industry. So anything to plan for us, the supply and the demand starts with the voice. So until end customer tells that they want something, the industry is not going to know, right? So in this part of voice of customer, I would say it is more of a role of a management team to take care of that. And they are the one who find out like what's there in the market and what we need. And that's more like a business analyst type of roles, right? And then they go and deliver those deliverables to the engineering design time, and it goes from there. All right, so yeah, we can go to the next one. As I mentioned earlier, Six Sigma has multiple levels of certification. To start off with, we have an yellow belt, green, black belt, and the master black belt. Here we have ASQ. It is like an organized, it's a really good organization who issue these certifications. And if you're interested to getting into manufacturing, and these all the certifications, I would say, potentially will take some time for you all to learn, because even when I was right out of college, I had no idea what these were, right? So, but once I got into the industry, it was much easier for me to learn all these things. But so if you wanted, you can start parallelly, checking the certification and getting prepared, because they are like really useful certifications. All right. So if you need any more details or guidance about these certifications, just reach out to me. So, all right. So the next topic is like we are entering into the second half of the topic for today is a quality management system. A quality management system is defined as a formalized system that documents, process, procedures, and responsibilities for achieving quality policies and objectives. Here again, quote more specific to the medical device manufacturing, and it applies to all manufacturing industries across. So the quality can never be compromised in any product. Say, for example, if at all we buy a phone, we look at different things, right? Starting from the specifications, the price, and the features, and moving so on. So we as customers, we are never ready to compromise on a quality. But how will an industry know, like, what are the standards and how do we maintain it? So every industries have a different quality management system. So right now, more specific to the medical device is what I am talking right now. And then we can go from there. So why do we have a quality management system is because you need a structure, and then it also is used for like meeting the customer needs, and we have certain regulatory requirements that is laid by the country which has to be met as well. To have all these in process, a quality management system works as a framework. All right, so some of the benefits are like, it improves the process, it controls the process, it reduces waste, which is again linked with Six Sigma, preventing mistakes, lowering the cost, facilitating and identifying training opportunities, engaging staff, setting organization-wide direction, communicating a readiness to produce consistent results. And here I would like to emphasize on identifying training opportunities. So when we as engineers, we get into an industry, right? Even though if it is gonna be like a beginner stage, we have always seen this requirement where, they need people with experience. And when I started, I quite didn't understand that. Why do freshers need some experience? So what they mean in an industry perspective is they don't mean the experience of like, the live experience, but something like, if you have a theoretical knowledge, they're trying to look for areas where they can actually put you and get you trained better. Okay, so if you're again for design, I would say if you have like, AutoCAD or something, you're not gonna go right away and start designing an equipment, right? So you have to go through a training. So each and every company, they have a system in place where they put you through certain trainings and until you start on like, your work. So yeah, so the basic knowledge that we have is really helpful and it translates into a big time. Yeah. Let me go ahead and go to the next one. So ISO 13485:2016. So this is one of the standard that right now we are using in the medical device, and it is designed by the ISO International Standard of Organization. They have laid out the terms and regulations which we have to follow for any things that we manufacture. This is more specific to the medical device. You have other ISO standards as well for automotive, and there's like every organization has a different set of standards. Every industry has a different set of standards. Okay, so I would say these standards are organizations involved in design, production, installation, and servicing of medical devices and related industries. So as engineers, when we start, looking for, when we wanted to get into the core industry, these are the areas that we will be like covering, right? So design, production, installation, and servicing. So all these four types of different domains is where they use ISO specific to medical device. They have to have that. And then also a product, I would say, for example, I would just quote on an iPhone, right? So an iPhone 10 is different from an iPhone 11, right? But there'll be like very minimum specifications, or internally they might be like, I might be wrong, but they might be like different types of systems changes or a software changes, right? How are we going to document that, right? So for things like that, you will have an ISO standard where things like that are documented. So for me, I would say from a medical device perspective, right, specific to like we have a pacemaker. So you have a pacemaker with configuration A and then configuration B. Maybe the only changes could be in software update, but how is that documented? Are we still following the the quality system. Things like that have to be documented. And also the regulatory requirements is very important when we make a change for a product. So things like that have to be, followed by the ISO standards and regulations. And also the other potential use for using the ISO standards is coming back to our to the product life cycle. If a product needs, additional specifications, or if there is a sudden change in the market where the product supply and demand is high, right? So those are the times when you have to use all these standards and revise your product. So that is where the ISO is used. And in the United States, the American National Standard Institutes are the one who regulate the ISO. In India, it's the Bureau of Standards, right? BSI. So this is what they do. And again, if you wanted to get into medical device, because medical device is something that's trending right now with everything that's going on in the world, you can touch base with these topics and just get a high level idea of what they do. All right, so we are almost close to that. So and apart from all of these, I would say I am also working with big data management. So that is one of the key areas of what I do on a day-to-day basis, right? So all the things that we discussed so far need some software, because without software, none of these are going to happen, right? There's nothing more manual anywhere. So these are some of the data analysis tools that are trending here. I mean, it could be the same in India also, but I don't have that much of knowledge of what is trending in India right now. But these are some of the data analysis tools. So for me, I basically use Tableau and Microsoft Excel. So Tableau is more like a data visualization tool. And NIME is one of the tool. It's again like a data visualization, which is being used across different companies like Walmart and Amazon here. Power BI, it's a Microsoft data visualization and analytics tool. Minitab. Minitab is more for a supply chain and statistical analysis tool, right? So if you wanted to, again, for supply chain, Minitab is used and things like that. And there's also many other uses for that. So these are some of the tools if you wanted to work in an industry where you wanted to use data, supply chain, engineering, and things like that, right? You can learn all of these. They're really helpful tools. Right. So I think we have come to the end of our presentation. So just let me know if you have any questions. We have close to 20 minutes left, and then we can go from there. Thanks, everyone.
Students, do you have any questions? Students, do you have any questions? You can ask. Is I audible?
No question, sir.
No question.
All right. Let's just.
Hi, ma'am.
Yeah.
Is there any certification you would recommend to us as a student you think we'll have to be equipped before getting into a job, be it IT or non-IT? Irrespective of our career, do you think is there any common certifications that will help us?
Okay. Common certification. I could talk more from from what I do right now. See, certifications when I used to study. I remember we used to go for the PLC. We learned PLC as well, and SCADA, but I'm not sure if the same technology is being used in the industry right now. So there's kind of a gap between the certifications and the curriculum to the industry. But if at all you're interested more of in manufacturing, I would suggest go start with learning Six Sigma, right? They're really helpful. And then you don't, I mean, yeah, once you're a professional, you definitely need a green belt, but an yellow belt certification is when you actually start with, it'll be more of a theoretical certification to start off with, to know about the basics. So that is one thing that I would suggest. Does that answer your question?
Yeah, thank you.
Yeah, you're welcome. Do you have any more questions here?
Any more question? Students, do you have any more question? I think we don't have any questions, ma'am.
Sure, sir.
Okay, ma'am. Shall we wind up the session, ma'am?
Yeah.
Now
Yes, sir. I
once
would just
again,
like,
ma'am,
yeah.
tell me, ma'am.
This is my contact information. Are you able to see? Okay, this is my
Yes.
contact information. So in case if you want to learn more about what we discussed today, you can reach me out at LinkedIn or through my email, and I'm very responsive in both the platforms.